on the back page, what we're going to do is we're going to graph our parabolas, but in formulas that look like this. Not anything that we've seen before, not like a standard form, but this is sort of like a vertex form. The directions say identify the focus, directrix, and axis of symmetry for the following parabolas, then sketch their graphs. So there's do's and don'ts for this, and I feel like the easiest thing to do is to thoughtfully make a table of values, and after you interpret, of course, the information that you are given. It looks like both formulas, there is no constants next to your x or next to your y. There are coefficients, which might affect how they open, left, right, up, or down, wide or narrow, neither, but we will not talk about that yet today. What I do notice, again, because there are no constants, is each of these has a vertex of 0, 0. So we're going to add that down here, that each of them has our first point of 0, 0. Okay. Next, there are lots of different ways for that I can teach this to you. And normally we plug in values of x and we figure out what the value of y is. But because of the way this formula looks to me, because we have a quantity squared on the right hand side, that means the left hand side has to be a perfect square. What I want to do is I actually want to plug in values of y and solve for x. It's a little bit different and untraditional. Let's make a mini table of values. Then what we'll do is maybe after finding a couple of points, maybe we'll graph it and analyze this stuff right here. We could do that first, and maybe we'll try that with our next one, but let's try to figure out what we're going to do. Like I said, we're going to pick values of y, and we're going to solve for x. Now, do we want values of y that are positive or negative? In order for something to be squared, the answer has to be 0 or positive. So if the first term is positive, then this also needs to be positive, or actually, you know what? 0 is a possibility. I'm going to fill in 0 here in the value of y. Now let's find the corresponding value of x. Plug in 0. 1/2 of 0 is, of course, 0. And to solve for x, square root both sides, which means plus or minus. 0, 0. Oh, wait a second. We knew that. That's our vertex. What's another good value to plug in for y? Would you want to plug in 1? Is 1/2 of 1 a perfect square? No, we do not want to plug in 1. But what we do want to plug in is maybe half of 2. Half of 2 is 1. 1 is a perfect square. 1 is the square of what two numbers? Positive 1 and negative 1. Okay, what just transpired? Plugging in 2 makes the left-hand side 1. Now we're solving 1 equals x squared. To solve for x, we have to square root both sides, but we have to do the positive and opposite square root of 1 to simplify our answers. So what's happening? We're going to have 2 points, or 2 values of x for every 1 value of y. Let's see what the next good value of y will be. Think, should we plug in 3? Half of 3 is not a perfect square. What about 4? Half of 4 is 2. We can try 5, 6, 7, but we won't get a perfect square until we use the number 8. Plug in 8. Half of 8 is 4. 4 is what number squared? There are 2 answers. 4 is the square of 2 and negative 2. All right. So what's the pattern here? Maybe you can see a pattern developing. 0 is a perfect square. 1 is a perfect square. 4 is a perfect square. These are double those perfect squares. 9 would be a perfect square. So double it. Let's put up 18 in here. 1/2 of 18 is 9. What number squared equals 9? That would be 3 or negative 3. I think we have enough points because 18 boxes will be off of our page. Let's see what this information is after we graph. So we have the point 1 to the right and 2 boxes up, 1 to the left and 2 boxes up. Okay, I feel like now we know this is the direction that it's opening. 2 boxes right and 8 boxes up. 2 boxes left and 8 boxes up. Connect these as smoothly as you can. So we have our parabola. Boy, that is a lumpy parabola. That is making me sad, but that's okay. So we have a parabola that looks like this. It's going to open up. Now, what about the focus and the directrix? Take a look at your 1/2. That 1/2 value is representing our 4p. 4py equals x squared. So that means 4p equals 1/2. Solve for p. Let's multiply both sides by 1/4. Our p-value, or divide by 4, is 1/8. Now, because the focus is above, because our parabola is opening up, we want our focus to be above, so the focus is inside. We know that is 1/8 above 0, 0. So we're going to add 1/8 to the y-coordinate of 0 of that vertex. There's your focus. It's very close. It's very close to that vertex. Down here, your directrix. Because it opens up, your directrix is this horizontal line underneath the vertex. If the focus is 1/8 of a box up, then 1/8 of a box below will be this horizontal line. Horizontal lines have y equals equations. Because it is underneath, instead of being 1/8 of a box up, it's 1/8 below, so the y-coordinate of there would be 0, negative 1/8. So y equals 1/8. Now, what is the axis of symmetry? Your axis of symmetry has to pass through your focus and your vertex. That is a vertical line. And it goes through the x-coordinate of your vertex and focus, which is x equals 0. That's what they share in common. So we made our first parabola. Let's take a look at number 2 down here. What we notice is the y is being squared. When the y is being squared, that means our parabola opens left or opens right. Traditionally, we like to plug in something here and solve for that. Today, we're going to notice that y is being squared, so the left side has to be a perfect square. Perfect squares are never negative, so if the first factor is negative, then what values of x make sense? We want to pick x coordinates or x values that are negative. Negative, and also that will turn our output of the left-hand side into a perfect square. So again, we can start with 0, because we already know that 0, 0 is the point on the vertex. Now let's think of perfect squares. Let's see, in order for this to be a perfect square like 1, so what I want to do is pick some number like negative 1/8 for x. If I plug in negative 1/8 for x, I get 1. What number squared is equal to 1? Well, that would be positive 1 and negative 1. Our next perfect square would be 4. What value of x makes the left side 4? That would be negative 1/2. And then that would make positive or negative 2. How about the perfect square 9? This could be a value of negative 9/8. And then we get positive or negative 3. We can keep going, so let's do that. Let's see, 16 is a perfect square, so let's pick a value like negative 2. If I plug in negative 2, that makes 16. That's positive or negative 4. Let's see, what's our next perfect square after 16? Like 25 now? Yeah, I think the odd ones are difficult. Why don't I try for 36 or something like that? Or maybe even, I don't know, 36, 49. Yeah, maybe let's do 64. 64 might be a nice one, right? So what I'm doing is I'm not rejecting all these other ones, but I feel like there are some answers or some values that work better than others, so I'm going to skip ahead. Let's pick negative 8. If I plug in negative 8, that gets 64. I get positive or negative 8. So a couple of these points might be a little bit nicer to graph, so let's try them out. Negative 8, positive 8, negative 8, negative 8. Ooh, our parabola is opening to the side. Negative 2, positive 4, negative 2, negative 4. Negative 1 and 1/8, 3. Negative 1 and 1/8, negative 3. All right, not bad. Negative 1/2, 2, negative 2. So you can see our parabola has taken its form. The more points we do in our table, the better off our picture will be. I can do a better job as the one than the one I did at the top. Easier said than done. So here's our parabola. Do you notice that it's opening to our left? So let's figure out why that is. If this is the equation 4px equals y squared, that means 4p equals the value negative 8. Divide by 4 to get the p by itself. P equals negative 2. Because it's negative, that's why it's opening left. If p is our directional distance from your vertex to your focus, and it's negative 2, that puts our focus right here. Our focus is the values negative 2, 0. If your parabola opens left to right, that means your directrix is vertical. Our directrix is the same distance but in the opposite direction away from your focus. So to the right, it's a vertical line, so x equals 2. And the axis of symmetry connects your vertex and your focus. That's y equals 0. So here's our second exercise, and that's how we're going to graph some parabolas in this chapter. I mean, we could just plug and chug, but you know, this is another alternative. Let's move on to our next section where we're going to use some information to come up with equations for parabolas.